Hi guys, this is Vicky and we are continuing with the 2015 AP Chem FRQ question number 2. And basically, if we're looking at this picture right here, we are collecting ethene gas right here, okay? So usually what I tell my students is this is like the, so here's the test tube and it looks like a hook, doesn't it? This part right here. This two-part where the gas is being collected. So that's the hook part. And if you look, this test tube that's kind of upside down, we can kind of be a little vulgar here, and that kind of looks like the middle finger, right? So I always tell my kids this is the hook and the FU picture, right? So basically what this is, it's got water down here and we are collecting gas, so ethene gas would be up here, and then we also have water molecules that also come up. So this water molecule, this is vapor pressure, okay? And we are going to symbolize it as this. And then the other one, these green gases, this is the partial pressure of ethene, okay? And collectively, the whole thing, okay, if you add them together, that's going to give you total pressure. Okay, so that's the main concept of these types of questions. And now that you understand this, we can continue and we can start answering the questions. So question number A. Okay, so basically it says ethene with molar mass may be prepared by dehydration of ethanol, and they gave you the molar mass for that using a solid catalyst. A setup for the lab synthesis is shown in the diagram above. The equation for the dehydration reaction is given below. So they gave you the equation here with delta H's and delta S's. A student added 0.2 gram sample of ethanol to a test tube using the setup shown above. The student heated the test tube gently with a Bunsen burner until all of the ethanol evaporated and gas generation stopped. When the reaction stopped, the volume of the collected gas was 0.0854 liters at 0.822 atmospheres and 305 Kelvin. The vapor pressure of water at 305 Kelvin is 35.7 torr. Calculate the number of moles. Alright, so first thing first, they want us to calculate the number of moles of ethene. Alright, so in order to find the moles of ethene, which is C2H4, okay, I mean the number of moles, and then they give you a bunch of pressure and all this information. So the first thing that kind of makes me think of this is the PV equals nRT formula, and I have pressure, but this pressure has to be that of what? Ethene, right? And how do I find the pressure of ethene? It's from up here, right? Vapor pressure plus the partial pressure of ethene gives me the total pressure. So we can actually do some math that way. So let's do this. So partial pressure or vapor pressure of water and the partial pressure of ethene has to equal total pressure, right? And what was the total pressure? They gave it to us right here, 0.822 atmospheres, 0.822 atmospheres. And that is that of ethene, okay? And they gave us the vapor pressure, and the vapor pressure is what? 35.7 torr. So 35.7 torr. If we look at this, we have different units. So let's switch this, okay, into atmospheres. Now, how do you switch that into atmospheres? So it's 37.5 torr. For every atmosphere, it's 760 torr, okay? And torr cancels out, and we end up with 470 atmospheres. Okay, now I can plug this number in, okay, to figure out what my partial pressure of ethene is, and I end up with 0.775 atmospheres. Now I'm going to plug this into there. And my volume, they have given it to us, which is 0.0854 liters. R is a gas constant, must be memorized, 0.0821. Okay, and temperature is going to be right here, 305. Okay, 305 Kelvin. And then if I do the math, I end up with 0.00264 moles of ethene. And that is my answer to A1. All right, A2. It says that calculate the number of moles of C2H4 that will be produced if the dehydration reaction went to completion. So this is assuming that all 0.2 grams of ethanol that was put in went straight to completion. So that's 100% yield, right? So this is just regular, simple stoichiometry. So I can just do 0.200 grams of ethanol. Okay, I know it's molar mass. First thing first, always if you get stuck, first thing first in chemistry and stoichiometry, switch it to moles. Okay, so let's switch this to moles, and that is how many moles? 46.1, right? Because they gave it to us, 46.1 grams to 1 mole of C2H5OH. Okay, and for every mole of ethanol is how many moles of ethene? 1-to-1 ratio based on the equation up here, right? So it's for every mole of ethanol, I have 1 mole of ethene. Okay, and then this cancels out, and we end up with 0.00434 moles of C2H4. Okie dokies, and that's it. All right, let's continue to B. So B, it says calculate the percent yield of C2H4. If you remember percent yield, it's always like the percentage of how much you got out of based on what you were supposed to get out of, right? So what was the actual volume that you collected or actual product that you collected versus the theoretical, okay? Theoretical. So what is the actual? You actually collected this much, right? So 0.00264 moles was how much you collected, and how much were you supposed to collect? 0.00434 moles, okay, times 100, and that gives you about 60.8%, and that is how much you ended up collecting. All right, good. Let's continue to C. Okay, and C says because the dehydration reaction is not observed to occur at 298 Kelvin, the student claims that the reaction has an equilibrium constant less than 1. Do the thermodynamic data for the reaction support the student's claim? Justify your answer. So in order for us to find out thermodynamically favorable or not, we're looking at delta G. And if we remember, delta G is equal to delta H minus T delta S. And easiest way to remember this is going home to study. It's a mnemonic, right? So going home to study. All right, so what is delta H? They actually gave it to you, which is up here. And what you need to always notice is this. Delta H, they always like to give it to you in kilojoules, okay? Whereas delta S, they like to give it to you in joules. So always just keep that in mind when you're trying to plug in numbers, okay? Because delta H will always be in the kilos, and then delta S's won't, all right? So that is 45.5. Temperature was 298, and delta S is 0.126 because I move the decimals, right? And I end up with 8.0 kilojoules per mole of delta G. Now that I have delta G, I can actually plug it into the K equilibrium equation, right? And K equilibrium is E to the negative delta G, okay, over RT. And if delta G is positive, the whole thing is negative, right? And if the whole thing is negative, then KP is going to be less than 1, right? It's less than 1. So yes, the student's claim is supported. Okay, cool. Let's continue to D. So what does D say? D says The Lewis electron dot diagrams for C2H4 is shown below. In the box to the right, complete the Lewis dot diagram for ethanol. Okay, so all it is I'm actually just going to do it on the picture here itself. And all it is, it's like I need to create at least one bond, okay, between everything, right? But how many electrons do I have in total? So C2H5OH, I have 2 times 4, 5 times 1, I have 6, and then I have 1. If I add them all up, I end up with how many electrons? 8, 5, 6, 1. That is 11, 12, that is 20 electrons. And how many electrons have I used up? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, 15, 16, 17, 18, 19, 20. Because oxygen is the only one that is electronegative enough to accept electrons. And remember, hydrogens, they can only create one bond, right? Good. All right, E. E says, what is the approximate value of COH bond angle in the ethanol molecule? So basically, it's supposed to look like this, right? H, 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 H. And then I have 2 lone pairs, right? So how many directions is this oxygen being expanded? 1, 2, 3, 4. Because it's 4 directions, right? It's what Vesper? It's a SP3, right? Because it's 1 plus 3 equals 4 directions, right? So if it's SP3 Vesper, remember in SP3 Vesper, we have tetrahedral, okay, something that looks like this, and that's tetrahedral, okay, and that would be 109 degrees, right? And then if I were to substitute one of those with a lone pair, it'll be like NH3, like so, right? So that's supposed to be, based on Vesper theory, it's going to be a little less than 109, so 105 degrees. And that was trigonal pyramidal, right? Okay, and then if I were to take another bond out and replace it with lone pairs, that's going to be less than 105 degrees, right? Sorry, this is supposed to be about 107. Okay, and that is bent, okay? So essentially, we just know that it's going to be somewhere around 109 or a little less than 109. And that's all we need to say. Okay, so it's a little less than 109 degrees. Okay, and that's the angle. And that's it. So I will see you guys soon on our next video. Okay, bye.